Task inputs and outputs, otherwise known as modeling tasks at functions. This is another really cool ability of Gradle. So if you think about it, most tasks can be described as functions. They have inputs, they have some processing that are applied to those inputs to generate some outputs. So the inputs can be files, configurations, and the outputs generally files. Gradle actually models inputs and outputs for tasks. So it has the concept of, okay, define this as being the input for this task and this being the output. And that enables some cool behaviors that you can get for free, basically, because we know that sort of stuff. So do not rerun tasks that will produce the same outputs. So if you think about it, functions, right? If you know about functional programming, they're all about having no side effects. Functions have no side effects. If you give them the same input, they will generate the same output. If you've defined your inputs and your outputs, and Gradle says, hey, your inputs is the same as last time I've run it, and you haven't fiddled with the output, I don't really need to do this task because we're sure that it will do the same thing. I don't need to run it, I can skip it. And we can say, hey, if I have a task and say the input from this task is the output from that task, then Gradle will automatically know that that task must depend on the other one. So you don't need to specify that. So there's an automatic dependency graph that can come up. Before you run the task, because you know what the input is, you know that, well, it has to be there if I want to run the task, so I can do that check first automatically for you. Because I know the outputs, I can create directories because I know that this is the output, so I know I'm going to need to write there, so I can create it before. This is all the stuff that you don't have to do in your actual task implementation. I can provide a clean task out of the box which goes through all the other tasks and removes their outputs, etc., etc., etc. So basically, you get a lot of advantages by having tasks know what their inputs and outputs are. Built-in task types already do this. So a lot of the Gradle input task types already do this for you. And if you're implementing your own custom task, like we did before, it's highly recommended that you provide the ability to specify inputs and outputs rather than just actually tell Gradle these are inputs and these are outputs, rather than, oh, here are some files. If that makes any sense. Because then you get all these wonderful things out of the box. So this is how you do that. But before I move on to that, there was some looks of confusion. Does anyone have questions about that? We'll do some exercise with it. So here we are. This is how you can do this when you define your own task. So here I am creating a task type. So when I said define your own task, I meant define your own task type. And there's our annotation from before. This is the action. And I've got all these other annotations on properties or attributes of the task. Remember that they can be set in your configuration that tells me, hey, I've got a text, which is a file, and it's an input file. So when I do my configuration and I say text and I give it a file, it knows that that's an input. So now it can do all that wonderful stuff and say, well, if that input hasn't changed since last time I ran this task, I probably don't need to run the task again, as long as the outputs haven't changed as well. Okay? And there's a number of annotations. Input files, input directory, just input string, output, and then there's the same for the outputs. So, as we've already sort of talked about, the killer feature that this enables is incremental building. So if you've run a Gradle build before, sometimes you'll see that it doesn't run some of the tasks, and it just says, hey, this task is up to date. And that means it's determined that this task doesn't need to run. So what that means is the inputs haven't changed since the last time I ran it, and the outputs haven't changed. Change detection is content, not time-based. So basically, we take a hash of the content of the inputs and the outputs and remember them. The next time you run the task, we do that again and compare the two. And if they're the same, then we say, well, we can skip this task, actually processing this task, because it's just going to generate the same output anyway.
you remember them where? So curiosity.
Sorry?
Remember them where? Is there like a .gradle directory or something hiding somewhere? Or? You said
Oh,
you remember them.
right. Sorry, I thought you said remember the where. Yes, there's a Gradle cache where a number of things are kept. One thing that sometimes trips people up while they are developing tasks is if you change the implementation of the task, Gradle has no way of knowing that. So it will come in and say, hey, the inputs and the outputs are the same as before, I don't need to run it, even though you've changed the implementation so it would generate something different. So at that point, that usually happens while you're kind of developing a task, and sometimes people get confused because they're like, well, I just changed it and I wanted to do something different, but I can't get it to run. Well, at that point, you need to clean the outputs so to force it to run again.
And it's kind of the bug. Yeah, it's clean plus the task with the first letter.
All right, so we just sort of mentioned plugins. So now we're going to talk about plugins, and this is another really powerful feature of Gradle as compared to, say, Ant. They're reusable build logic. So the tasks were reusable chunks of tasks, but you can actually have, if you imagine you wrote yourself a build file, you can actually have that applied by default. So that you have to write much less build file as long as you subscribe to some conventions. You can just apply the plugin for the technology you're working in, and usually it'll do most of what you want a lot of the time. So they can do everything a build script could do. So yes, if you didn't have that plugin, you could replicate everything it did by writing a build script. So it just reduces the size of your build script by adding stuff to your build script automatically. So you apply a plugin and you'll get a lot of tasks. So we applied the base plugin and it automatically added the clean plugins for every task that we defined, clean tasks for every task that we defined. Yep. So there are two ways to, so this starts to come back to your question before about splitting huge long build files and how you separate them out. Plugin is a good way of separating out standard approaches that you want to reuse. Script plugins are applied by path, so you can just have a groovy script sitting in your directory file somewhere and you can apply it to your build file like that. Or you can build a plugin as a jar, as a binary distribution written in jar if you like, and then as long as that jar is available on your class path, you can apply a plugin like that using an ID. So, Gradle ships with a whole lot of plugins. The Java plugin, for example, that base plugin. There's a Java base plugin as well, but there's a whole lot. If you look at the user guide, you'll see a chapter for each of them. However, there's a whole community of third-party providers that also provide plugins for interesting stuff. So you would have seen in the keynote this morning a new portal where you can find out about all of those. Obviously, the Gradle distribution isn't going to know about how to find a third-party plugin, so you have to tell it in the build script section. So you're saying, my build script has some dependencies because I use a plugin. So for my build script dependencies, I'm going to use Maven Central, and I'm going to say I require this SSH plugin. And so now in my script, I can apply that plugin. Does that sort of make sense? So probably two concepts here is that the first thing about, well, you have to be able to say where to find the jar. And the other thing is to realize that this is a dependency of your build script, which is different from the dependency of your projects, which is why it's inside a build script tag.
You have to pull it every time?
Sorry?
You have to pull it down every time?
No. No. Gradle will cache it for you.
Is there like an ID cache or Gradle cache?
Will cache.
Okay. Unclear about
Yeah. So, well, configuration phase sets up the dependencies for your class path. You say apply this plugin SSH. When it comes to do that, it will lazily resolve the dependencies when it needs to.
And how does it, this piece on the class path identify itself as an SSH plugin? Some properties.
Okay, it doesn't say here. So because mainly what we're talking about here is using plugins, but to oh, sorry. The question was, I think, how does it know that this SSH means this plugin, right? So that's something you need to know if you're writing your own plugins. Basically, in the jar on the class path, there's a file with a standard naming convention, and in that file it has a property that tells you what the plugin ID is. So basically, it will look for a file that has this in its name, and inside there, other way around. The file is named after the plugin ID, and inside there it'll tell you what the class implementing the plugin is called.
As a user, you need to look it up in the documentation.
Okay, but anyway, so as I said, Gradle comes with a whole lot of standard core plugins. So quite possibly you won't need to use any third-party plugins. So Java, checkstyle, a Maven plugin here, which is used for uploading to Maven repositories. Scala, IDEA, and Eclipse, which help if you're using IntelliJ or Eclipse as your IDE. So you don't need to set the project up yourself. You can just generate a file that you can use. Application plugin, which allows you to create an installation of a Java application that you can run with start and stop scripts, start scripts anyway. And this morning we were talking about native binary support, so that's applied by a standard plugin. There's many more. You can find them in the Gradle user guide. There's a chapter on each one. Let's talk about one in particular, the Java plugin. So it's the plugin for developing in Java. And basically what it allows you to do is if you obey a few standard conventions, which are pretty much also the conventions that Maven uses, you can say apply plugin Java, and for a simple Java project, you already have in that one line created a build file that will allow you to do pretty much everything you need to do. You'll be able to create a jar, you'll be able to run tests, you'll be able to compile the code, you'll be able to process your resources, all that sort of stuff that you generally do in a Java project. You'll have tasks and dependencies set up for you to do that. So the Java plugin introduces the concept of source sets. For newbies, a point of confusion often is that people don't realize that source sets are a Java plugin thing as opposed to just a Gradle thing. And then some conventions on top of that, which say, we expect that in your standard Java project, you'll have a main source set, which has your production code in it, and you'll have a test source set, which has your test code in it. And as I said, a whole lot of stuff comes free out of the box. Compilation, pre-configured, it knows how to compile, it'll have a task to compile Java, it'll have a task to compile your tests. It has dependency management out of the box, so you can declare dependencies. If your Java code uses a third-party library, you can tell. And it has the dependency management configurations pre-configured for your runtime and your test time and your compile time, all that sort of thing. JUnit and TestNG testing out of the box. It'll have a task to produce a jar, a task to produce Java documentation, configuration, simplified configuration for publishing your jar to Maven or Ivy. You'll get the IDE integration, so I'll be able to say Gradle IDEA, and then I'll have an IDEA project file that I can open. And basically a standard lifecycle interface for a Java project, which is really useful as a base. So let's talk about source sets a bit more. Basically, a source set is what it sounds like. It's a set of source. So it's a logical grouping of a number of source files. It's a Java plugin, so they're Java source files. You also have the concept of non-compiled source files, so files that are not going to be compiled, properties files. There's a number of class paths. So if you've worked in Java, you know that you've got your compile time class path and your runtime class path. And then you're going to have your test compile class path and your test runtime class path. And they're going to be interrelated. They usually extend from each other. That's all set up automatically for you with the Java plugin. Outputs set up for class files, so you get that up-to-date checking, all that sort of thing out of the box. There's compilation tasks, as I said, compile Java, compile test.
I noticed folder structures like Maven, where it's from. What about Gradle? Does it have to comply with certain folder structure as well?
By default, it expects that you are following the same convention as Maven. So your Java will be in source main Java, your runtime resources and source main resources. This is an example of how you can change that, but it's actually setting as the defaults. So if I didn't do this block at all in my build, and I just put my files in source main Java, sorry, the question was, do I have to put my source where Gradle expects it? And that was the question basically, right?
Is it the same as Maven?
Is it the same as
Or
Maven?
does it have,
Right, by default it's the same as Maven. Sorry. It's good you asked me to repeat the question because I didn't understand what the question was the first time. Yes, by default it's the same convention as Maven, but you can change it, and this is how you change it. Here we're setting it back to the defaults, which is a bit silly, but you can change it if you want to, and everything will then work. All the other stuff will know where to find everything. You get a whole lot of tasks, lifecycle tasks for your Java project with the Java just immediately. Obviously, the clean task, clean all your build output. Classes, which will compile your code and process your resources and create all the classes that you're going to use at runtime. Test will run all your tests. Assemble will, well, obviously it needs the classes, so it'll run classes if classes is not up to date already, and then assemble it into a war, a zip, or a jar. For the Java plugin, it's going to be a jar. There's a check task, which will run the quality checks. So the Java plugin, we're talking about JUnit or test-ng tests. If you've also applied the check style plugin, then the check style plugin adds the check style check to that check task. So then check will run your tests and your check style. So you can see how plugins start to add incrementally onto each other. And then a final top level one, which is a combination of assemble and check. So that does everything. As I said, there's built-in support for JUnit and test-ng testing. So out of the box, you get a pre-configured test task. It automatically finds your tests in your test source set. You can control forked JVM execution, so your tests run in an isolated JVM. There's out-of-the-box support for parallel execution of tests. You can configure how much console output you get from running your tests. And then there's also out-of-the-box reports generated, HTML. So CI server sort of, if you use JUnit, you get your JUnit XML report, and it also gets formatted in an HTML report. And all this comes for free with the Java plugin. So if you've ever sort of set that up with Ant, for example, and you know when you start a new Java project, you usually have this sort of base Ant file that you copy and paste from somewhere that does all this sort of stuff. Here, that base file is apply plugin Java.
Can you supply your own JVM parameters into the JUnit?
Yeah. So like that, the Java plugin provides this base, and then because, sorry, the question was, can you supply your own, for example, your own JVM parameters into the test JVM? So yes, the Java plugin applies a standard lifecycle and standard defaults, but then your build script is just Groovy code. So one, you can change how the tasks depend on each other, all of that, and those tasks expose configuration APIs, so you can configure them differently from their defaults, and that's one of the configuration APIs that is exposed on the test stuff.
Max Pro
All right,
works.
we're kind of running out of time, so we'll need to move along here. So I'll just quickly run through the steps like last time, and then we have a feature tour of some of the interesting features of Gradle that you probably want to know about. You would have seen, hopefully, in the first step when you ran Gradle tasks that there was a whole lot of tasks to do with Java project development, compile Java, all this sort of thing. So, and that just came from that, basically from that one line apply Java plugin. One of those tasks would have been jar. So when you ran that jar, you would have found that it built a jar from your source main directory and your process resources and put it in the build directory. The clean task, like before, would have cleaned your build directory for you. So then if you ran the jar task again, it would have created it again. Did anyone get up to editing the source code of a test? Right. So then you would have been able to see that you could run the tests using the test task, and you would have got a report out, and you would have been able to see the failing test in your HTML report. Found that under build reports.
There's a nice feature on Mac and some Linux to open the HTML test report. You command double-click the URL that's printed, the path, and it opens it automatically in the browser. You don't have to copy and paste the URL into the browser. And command double-click the URL if you have failed tests.
The next step would have been to show an example of configuring the tasks to operate slightly differently than their defaults. So the example we're using is having the tests run in parallel. So the test task exposes a configuration API, you apply a configuration block, set the appropriate flag, and you would have found that your tests would run in parallel. Right, did anyone get up to this far? Yeah, all right. So if you've got up the next thing was to move the production sources from their standard place in source main Java, and then you can configure Gradle that they're not in source main Java anymore. If you got up this far, you can add stuff to the jar that's created if you want extra metadata by once more configuring extra stuff above and beyond what you get with the Java plugin. If you guys are using IDEs, then Eclipse and IDEA have tasks that will generate project files for those. So that's really useful because you don't have to go through and manually set up all your dependencies and import your dependency jars so that you can compile an Eclipse. You put them in your Gradle file one place, it works for the Gradle file, and it automatically works for your IDE as well, which is really cool. Okay. So that was the Java plugin. Hopefully you sort of got the idea that plugins are really powerful things. As long as you're prepared to put up with doing things in a convention, then you don't need to, it saves you a lot of boilerplate coding when you're going to do everything the same on every project, and yet at the same time still leaves it very open to configuration and adjustment, because everything exposes a configuration API, and on top of that, your scripts are just groovy, so you can do pretty much anything you like. All right, we've only got a few minutes left, so a small selection of useful features that probably useful to know about. We have a thing called the Gradle Wrapper. So I think a lot of people used Ant here. If you use Ant on a project where a lot of developers are using Ant, a common thing is to check ant.jar into your source repository so that everyone's using the same version of Ant. Gradle provides a wrapper to get that same sort of approach. Basically, one person has to install Gradle that first time, create some wrapper data, and check that in. And then anyone who runs that build, the Gradle wrapper will go and automatically get the correct version of Gradle installed on their machine. So you don't have to worry about different developers in your team running different versions of Gradle. You can decide to upgrade for everyone all at once, and the next time they pull from the source repository, they will automatically, the Gradle wrapper will automatically go and upgrade everyone to the next Gradle. The difference is that instead of using Gradle on the command line, you use Gradle W, which stands for Gradle Wrapper.
Also really useful on CI. You don't have to install it on CI, because even CI will just patch. Use the same bootstrap.
One of the slight disadvantages of Gradle is that in order to process all those groovy files, you have to start up a groovy runtime, a Java JVM. That can be quite slow. So we provide a daemon where that just runs in the background all the time. And actually, if you remember way back when we started, and the first thing, one of the things we did was set a property to say daemon true. So you guys have been using the daemon this whole time. And what that means is that it doesn't need to start up the runtime the whole time, so it avoids that. You've got a runtime there the whole time that we'll use. That's probably all it does at the moment. In the future, it'll be used to even more optimization. So maybe it will remember configuration rather than actually have to run every time, not only start up, but run every time as well. But at the moment, it's very useful in making things faster. The Init Plugin. Basically, you can install Gradle, type Gradle init with a type, and it creates a build a project structure for you. This is sort of like archetypes from Maven, I guess. The other thing that it can do is if you type Gradle init in a build that is already a Maven build, it will do a reasonably good job of converting that Maven build to a Gradle build. It's probably overpromising to say it'll just everything will automatically work, but hopefully you'll get 80–90% of your Maven build converted. Continue after failure. By default, if any tasks fail, Gradle will fail the build at that point. You can tell it to continue and run the next task even though those ones failed. It's kind of useful if you're running a CI build where you want to run your unit tests and your integration tests and everything, and you actually want to know the output from all of them. By default, Gradle will fail at the first test failure. But then you can say, well, continue, even if there are test failures in the unit tests, continue and run the integration tests as well. Parallel builds. This is an incubating feature, so it's not quite perfect yet. But it means if you have a big project that has several sub-projects, and so running the whole thing ends up running this sub-project's build, then this sub-project's build, then this sub-project's build, you can use this flag so it'll run the sub-project's build in parallel. It won't run tasks in parallel. That's a sort of future something that's coming in the pipeline. But this at least will allow you to parallelize your multi-project builds to some extent.
Just continue. Like sometimes there are some cases where you run your build and it fails somewhere in the middle, then you just want to change one line or something, and you want it to build over, but pick up from where it left off without reviews or something like that.
So remember, if your tasks have defined their inputs and outputs correctly, then it should skip all the tasks that have already been done up to the one that. So yeah, Gradle just does that. That's what Gradle does. All right. And 48. And I will just use that last minute to repeat that question for the video. The question was, if you get to a certain point and a task fails, and it may be halfway through a very long build, and then you want to, you realize you made a mistake, so you fix something, and you want to rerun it again, is there a way of saying start from where I left off? And my answer was, well, actually, with the up-to-date checking in the inputs and outputs we were talking about before, Gradle should just do that anyway. So all the tasks that have already run and their inputs and outputs haven't changed, they won't run again. So it will effectively skip to where it was. Okay, and hopefully that's been a reasonably good intro to Gradle. There's much more to Gradle. We haven't even talked about dependency management, which is obviously a very important part. But hopefully you found that useful. We now have a minute for questions. So were you in the Groovy?
I came late.
All right, okay. So, oh yes. So if the build file is valid Groovy, how did we manage to apply that syntax? Via trickery. So apply is going to be a method on the project class. So then what happens? Do you know, Peter, off the top of your head?
That's correct, yeah.
And
it's
then
name parameter. The plugin column.
Right, yes.
Is the name parameter. The name parameter is plugin, and the value is the string you pass in. So you call a method and pass a name parameter. That's what it's on the Google level.
And so I don't know if you were there for that bit, but you remember I was talking about name parameters are actually maps. So that is actually syntax for a map, but because it's Groovy, you can remove all the outside stuff, and it just looks like you've... So it's actually pretty simple once you know what's going on. Allows you to do that. Other questions?
What is the coolest feature of Gradle?
What is my favorite feature of Gradle? Oh, that's a tough one. For me, it's the build file is a Groovy script. It's a code. You know, compared to trying to write code in XML in Ant, or trying to declaratively put things in XML in Maven, and then pretty much the only mechanism that Maven provides for you for modify is to write a plugin, which is whereas Gradle allows you to quickly hack in some code to get your build running, and yet you can still extract that into a plugin and share it later if you want to. It's probably if I had to choose one, that would be it. What about you, Peter?
For me, it's probably the input-output model, so you transfer information.
So for the video, Peter said the things we were talking about with the inputs and outputs, and how if you tell Gradle about that model, it can infer a lot of stuff that it can do for you. And that's actually fundamental to Gradle's approach. It's not imperative where you just say, do this and do this and do this. You describe your situation, and from that, Gradle can magically know a whole lot of things that it can do for you. Whereas in an imperative build language, you actually just have to tell it everything and how to do it. So here you tell it the what instead of the how more often.
Are there any tools out there that...
The question was, are there tools out there to help with visualizing your task dependency graph? The answer is yes, there are. Is there anything that we provide out of the box? There are third-party plugins that do that. That's something that I would like to see done better, because especially when you have multiple plugins applied and they all change the task graph slightly, it can sometimes be interesting to at the moment, without applying that third-party plugin that allow you to do that, you kind of have to look at the task graph for one plugin and for the other, and then mentally merge the two. But yeah, there are third-party plugins that do that.
I think Resi is working on something like that.
Gary, you never told us your favorite Gradle feature.
My favorite one. The flexibility of being able to extend stuff.
So in case the video couldn't hear that, he said his was the same as mine, which was a cop-out if you ask me, but anyway. Okay, well, if there's no further questions, thank you much, everyone. I hope that was useful.